Today I will introduce you to Wilcoxon test. Wilcoxon test divided by two tests which are rank sum and signed rank test. Both of them are proposed by Frank Wilcoxon. He is an American statistician. In 1945, Frank proposed both rank sum and signed rank tests in a groundbreaking published research paper. The test laid the foundation for hypothesis testing of non-parametric statistics, which are used for population data that can be ranked but do not have numerical values such as customer satisfaction or music reviews. Non-parametric distribution do not have parameter and cannot be defined by an equation as parametric distribution can. Our main focus is signed rank test. Wilcoxon-signed rank test is a non-parametric statistical hypothesis test used when comparing two related samples, matched sample or repeated measurement on single sample, such as pre and post test, to assess whether their population mean rank differ. It is equivalent to matched sample t-test, so we can think of the Wilcoxon-signed rank test as the non-parametric version of the matched sample t-test. Wilcoxon-signed rank tests allow us to compare two populations that violate the assumption of normality. The purpose of this test is to test whether the medians of two paired sets of measurements from a same identifiable population are different from each other. The only requirement of this test is that the distribution of differences, median, is symmetrical. It is not necessarily normally distributed. When Wilcoxon test, the test statistic is reported as a value of t. Similar to rank sum test, signed rank tests take into consideration the magnitude of difference among the pairs of values. Rank sum tests only consider the direction of differences but not the magnitude of differences.
For assumption, data are paired and come from the same population. Each pair is chosen randomly and independently. The data are measured at least one interval scale. Within pair difference are calculated to perform the test.
This is the Wilcoxon-signed rank test in Excel. And as follows, the null hypothesis is that there is no difference between quality of two samples, and the alternative hypothesis there is a difference between two samples. So here we have 16 bars for brand A and brand B, 16 data. First, we are going to assess the difference between the two brands. So I'm going to go equal brand A minus brand B. Then I'm going to copy the formula down to all of the cells below using Ctrl+C and Ctrl+V. Next, I'll be doing the absolute difference. So we'll do minus and equal absolute of the difference, and I'm going to copy and paste that one down. Notice now that the four negative differences have just become positive. Now we're going to rank the differences. We want to know which differences is more extreme and which difference were least extreme. So I'll be going equal rank.average. We take the absolute difference and then we drag all the way down, and then we're going to choose 1 for ascending order. We're going to put the dollar signs around the letters for the dataset so that it doesn't move when we copy and paste the formula. Next, we're going to calculate the positive and negative ranks. So equal if open bracket difference more than 0, and we choose rank of absolute difference, close bracket. And same as the steps before, we copy and paste all the way down. And for the negative rank, just the same as the positive. It's just that we will be using less than 0 instead of more than 0 because it's negative. So the next step, we'll calculate the total for the positive rank and the total for negative rank. So we're going to do equal sum all of the positive rank, close bracket. And we will get 101.5. Same goes to the negative rank, equals sum all of the negative, and we got 18.5. So the 18.5 will be our test statistics. To calculate the test statistics, there is another formula, equal minimum, open bracket, sum, and open bracket. We drag all of the positive rank, close bracket, and then we add another sum, open bracket, and drag all of the negative rank, close bracket. And we will still get the same value, which is 18.5. Next, we'll be calculating the sample size. Equal count, open bracket, we drag all of the positive and negative rank, and close bracket, and we will get 15. The sample size for our table is 15. And to determine if we should reject or fail to reject the null hypothesis, we can find the critical value that corresponds to alpha 0.05 and a sample size of 15 in the Wilcoxon-signed rank test critical value table. So as the former presenter had presented, or maybe before, the sample size is 15 and the alpha value is 0.05, so our critical value will be 25. The critical value that corresponds to alpha 0.05 and the sample size of 15 is 25. Since the test statistics 18.5 is less than the critical value of 25 of 15, of 25, we reject the null hypothesis. We have the sufficient evidence to say that there is a difference between quality of two samples, brand A and brand B. So that's all for the Excel. Thank you.
Okay, firstly, you need to read the question so that you will know what to state in the hypothesis, and make sure to use 5% level of significance, and as you can see, data are given in the table. And then we start with the first one, which is state the hypothesis. The first one is null hypothesis, which is there is no significant difference between perceived quality of two samples. And the second one is alternative hypothesis, which is there is significant difference between perceived quality of two samples. Okay, let's move on to the calculation. Okay, we start with calculate the difference A minus B, which is brand A minus brand B. For example, 73 minus 51, then you will get 22. 43 minus 41, then you will get 2. Same goes for the others, and you can calculate all the way down, and then you will get the difference. As for the absolute difference column, we can just simply remove the negative sign that we calculate in the difference between A and B, which is like -1, -10, and -2. So then it will be easier for us to arrange them according to the rank. After arrange them according to the rank, as you can see, number 2 and 4 appear twice, which is to determine their rank, we need to calculate the average, which is number 2 have 2 rank, which is 2 and 3. You need to 2 plus 3 divided by 2, and then you will get 2.5. Same goes with the number 4. After that, arrange them according to two groups, which is positive and negative. For example, if they are with the negative sign, then put them in the negative rank column. Same goes with the positive rank. After that, you need to calculate the total.
Find the T positive, we have to sum all of the rank that have positive sign, and the total we get is 101.5. While T negative is sum all of the rank that have negative sign, and the total we get is 18.5. So to get the test statistic, we must find which value is smallest. T negative is smallest than T positive, so the test statistic is 18.5. After that, we look at Wilcoxon-signed rank test table to find the critical value. Since the pair number of A, there is no significant difference between brand A and brand B, so the total sample number is reduced to 15. So we choose the alpha 0.050 for two-tailed test from the table, as this question was required of 5% level, and choose the total sample, which is 15. So we get a critical value for alpha 0.050 for two-tailed test is 25. So we can see that test statistic, which is 18.5, is less than critical value, which is 25. To make the decision, we have to look between calculated value, which is test statistic, and critical value. Since calculated value 18.5 is less than critical value that we pick in table, which is 25 of W at 5% level of significance, so the null hypothesis rejected. In conclusion, there is significant difference between the perceived quality of the two samples, which is brand A and brand B.
HASSAN rank test. First, we have to make hypothesis. Second, we have to find the difference between two measurements. And then, at the absolute difference column, we have to neglect positive and negative sign. Step number 4, we have to assign rank. If 2 or more are equal, calculate the average, and then reassign the symbol, positive or negative, depending on the original. And then we have to find T positive and T negative as a T statistic. Step number 7, we have to find critical value, and then compare the critical value with the T statistic value. And last step, we have to choose the right hypothesis.